and welcome to this example on annuities. An annuity is a series of payments, usually in equal amounts, that are made at regular intervals for a fixed period of time. Consider the example we have right here. Lawrence contributed $4,375 at the end of every 6 months to a registered retirement savings plan fund earning 7.02% compounded semi-annually for 15 years. There are 2 questions. First, what was the future value of the fund at the end of the term? And second, what was the amount of interest earned over this period? And we need to round answers to the nearest cent. To work with this problem, we need to identify various variables. So let's introduce some notation. The $4,375 correspond to the amount of the periodic payment of this annuity. We write PMT equals $4,375. Now we have that amount of money is contributed at the end of every 6 months. So we can say that the payment interval, and that's also called the payment period, is 6 months. Because 6 months pass between 2 successive payments. With that payment interval and the 15 years that we have here, those 15 years are the term of the annuity, we can compute the total number of payments during the term of the annuity. That's usually denoted by N. We multiply the number of payments per year by the time period in years. Because payments are made every 6 months, we have 2 payments per year. And then we multiply that by 15, we get 30. So Lawrence made 30 payments in total in a time span of 15 years. So here we have the number of payments per year is 2. Okay. Next, we work with the 7.02% we see in the statement of the problem. 7.02% is the nominal interest rate. That's usually denoted by J. So we have J equals 0.02%. And we have that interest is compounded semi-annually. So the compounding frequency, and that's usually denoted by M, is 2. The number of compounding periods per year is 2. With J and M, we can compute the periodic interest rate, the interest rate per compounding period. We find that periodic interest rate, and that's denoted by I, is J divided by M. So we have 7.02% divided by 2, and that's 3.51%. Or we can use decimal numbers. Remember that when it comes to calculations, we want to see percentages as decimal numbers. We have 0.0351. Okay. So we have covered everything from the statement, and we introduced variables involved. We have that the amount of the periodic payment of this annuity is $4,375. The payment interval is 6 months. The term is 15 years. The number of payments per year is 2. The total number of payments during the term of the annuity is 30. The periodic interest rate is 0.0351. the nominal interest rate is 7.02 and the compounding frequency is 2. Now, we can classify annuities according to various things. In particular, we can say that the annuity we have right here is an ordinary simple annuity. This annuity we have right here is ordinary because payments are made at the end of each payment period. We have that Lawrence contributed the amount of money, PMT, at the end of every 6 months. That's an ordinary annuity. And in this example, the compounding period and the payment period are the same. Here, Lawrence is contributing $4,375,000 at the end of every 6 months, and interest is compounded semi-annually. So we have that the compounding period and the payment period are the same. So we're working with an ordinary simple annuity. And working with that type of annuity, when we work with that type of annuity, we use certain formulas. So it's very important to classify the annuity before trying to solve a problem, because depending on the type of annuity we have, we get to work with certain formulas. Okay, now that we have talked about variables involved and the type of annuity, let's jump to part A. So let's find the future value of the fund at the end of the 15 years. A simplified formula to calculate the future value of an ordinary simple annuity like the one we have here is given by future value equals PMT multiplied by 1 plus I to the n minus 1 over I, where n is the number of payments during the term, PMT is the amount of periodic payments, the amount of the periodic payment, and I is a periodic interest rate. In our case, we have 4,375 multiplied by 1 plus 0.0351 to the 30 minus 1 divided by 0.0351. I've just substituted all values we talked about before into the formula for future value. And if we use a calculator to compute future value, we find a number that can be approximated by $226,221.25. If you're using a calculator to compute future value, make sure to go with something like this. You have 4,375 multiplied by bracket, then another bracket, then another bracket, 1 plus 0.0351 to the, then bracket 30, take away 1, close bracket, divided by 0.0351, close bracket. Okay. So there we have this. Now for part B of this problem, so we're done with part A. Let's move on to part B. To work with part B of this problem, we use a formula, another formula. The amount of interest earned is equal to the future value of the investments minus the amount invested over the term. And the amount invested over the term corresponds to n times PMT, because Lawrence contributed $4,375 twice a year for 15 years. The total amount she contributed, or they contributed, is n times PMT, where n is 30 and PMT is 4,375. So here, to find the amount of interest earned, we do 226,221.25 take away the product of 4,375 by 30. And when we compute this amount using, for instance, a calculator, we find 94,971.25. So that's the amount of interest earned. And this is the answer to part B. And this is the answer to part A. Okay. So to summarize what we did, we started by identifying variables involved in this problem. We worked with the amount of the periodic payment of the annuity, the payment interval, the term of the annuity, the number of payments per year, the total number of payments during the term of the annuity, nominal interest rate, the compounding frequency. Then we computed the periodic interest rate based on the nominal interest rate and the compounding frequency. Then we classified the annuity as ordinary and simple. And then based on that classification, we said that for part A, we use the formula future value equals PMT times 1 plus I to the n minus 1 over I, right? And then to find the amount of interest earned, we did future value minus n times PMT. We take the future value of the investments and we subtract the amount invested over the term. All right, if you have questions, please write a comment or contact me and I'll do my best to help. Thank you for watching. Bye-bye.